Module 4.6, Intro to Lab 4, Standing Waves in a Tube. In Lab 4, we're going to observe what we learned this week about standing waves in a tube. First, that standing waves occur in tubes only at harmonic frequencies, as defined by the formula F equals NV over 2L for a tube open or closed at both ends, or F equals NV over 4L for a tube closed at one end. We'll see that a tube closed at both ends will resonate at all harmonics, and that a tube closed at one end will resonate only at odd harmonics. We'll see that nodes are points of minimum pressure change and antinodes are points of maximum pressure change, and that nodes occur at open ends of a tube and antinodes at closed ends of a tube. We'll see that nodes and antinodes are evenly spaced at the distance of half a wavelength, and that the speed of sound can be determined using the wave equation F equals V over lambda. We will use the following equipment: a wave resonance tube that has a speaker and a microphone, a signal generator, an oscilloscope, a meter stick, and your good friend, the vernier caliper. To start off, turn the signal generator on. Adjust the voltage to 1 volt. Do not go above 1 volt, as the speaker, which is not replaceable, will burn out if too much voltage is applied. The frequency should have defaulted to 1000 Hz. Connect the speaker to the red and black jacks on the front of the signal generator. Open either end of the tube. Make sure you hear an audible tone coming from the speaker. Close the tube by replacing the end cap. Connect the microphone to the channel 1 input of the oscilloscope. Turn on the microphone. Press the trigger menu button, press More, press Coupling, and turn the multipurpose knob to select Noise Reject. Push the multipurpose button, then turn off the menu. Move the microphone so that it is at the speaker end of the tube. Measure and record the length of the interior airspace of the tube with a meter stick. We'll now look for the resonant frequencies of a tube closed at both ends. On the oscilloscope, set the display to 10 millivolts and 400 microseconds. On the frequency generator, start at 400 Hz and gradually increase the frequency of the signal generator while watching the waveform on the oscilloscope. You may need to adjust the controls to get a full waveform on the screen. Adjust the frequency so the waveform is at a maximum and record the signal generator frequency. This is the fundamental frequency of the tube. Adjust the display so there is one cycle of the waveform and take a screenshot of this waveform. Repeat for the next 8 harmonics. You only need a screenshot of the fundamental frequency, not the other harmonics. Once you've done that, we'll look at the resonant frequencies of a tube open at one end. Remove the end cap with the microphone from the tube. Measure the length of the interior of the open tube with a meter stick. Note that the length of the tube will be longer than your previous measurement because the end cap is off. Measure the inside diameter of the tube with the vernier caliper. Insert the microphone all the way into the tube and make sure the end plug is away from the open end. Starting at 200 Hz, gradually increase the frequency of the signal generator while watching the waveform on the oscilloscope. Adjust the frequency so the waveform is at a maximum and record the signal generator frequency. This is the fundamental frequency of the tube. Adjust the display so there is one cycle of the waveform and take a screenshot of the waveform. Repeat for the next 8 resonant frequencies. You only need a screenshot of the fundamental frequency, not the other harmonics. Now we are going to find the antinodes in the tube. Replace the microphone and end plug into the tube and retune the frequency of the generator to the 7th harmonic of the closed tube. Move the mic to the speaker end of the tube. Record the position of the microphone using the scale on the side of the tube. Slide the microphone slowly across the length of the tube and record the positions of the microphone when the output signal is at a maximum. These are the antinodes, and they are at half a wavelength apart. Next, remove the microphone end cap and repeat. Be sure to use the frequency for the seventh harmonic of a tube opened at one end, and make sure the end cap is away from the open end. If you need graphing help, it's in Blackboard in the Lab Write-Up Resources folder.